Hello, and welcome to a little video about the KC1 test. I'm just going to go over the review, explain the problems out loud in case this is a study tool that might be helpful. All right, number 1. David rode his bike to the park. After staying at the park for a while, he continued to ride to the grocery store. The graph shown represents the situation. Let's talk about the domain and range. So your domain is how far left and right that you go. Well, we begin at 0 on the left, and then I trace my graph all the way to the right, and it looks like it ends at 50. Your range is how far we go from the bottom to the top of the graph. Whoops. That was a line by accident. Let me erase that real quick. There we go. So our graph begins at 0. So I'm going to go ahead and write 0 right here for the range. And it ends right here at the very top. So let me just draw a line out so I can see better where it ends. And it ends right between 2 and 3. So I can safely say that it's 2.5. All right. Letter B asks us if the graph is increasing, decreasing, both increasing or decreasing, or constant. All right, and asks us to explain. So explaining means show me your mathematical proof. Let's see. At the beginning of my graph, at 0, I start to rise upwards. So that means increasing. And it looks like I stop right about here. So between 10 and 20, that's 15. So I'm going to write I for increasing, 0 to 15. Okay, what happens next? Next, I'm just flat all the way to 40. When it's flat, that means it's constant. So from 15 to 40, we were constant. Well, what happens next? Now I begin to trace my graph from 40, and it looks like it's going up again. So that means I'm increasing from 40 to 50. Beautiful. Next, number 2, determine whether or not these are functions, and let's explain why or why not. I will save the writing because it's not, my handwriting isn't that great on the computer. So I'll just explain to you out loud, and hopefully that will be good. If you want to see it in words, make sure to click the closed caption button, and you'll be able to see the explanation. All right, number 2. For a graph, what we do is we draw a line. Let me pick a different color. We draw a line that goes straight up and down through the U-shaped graph. Now I'm going to see how many times my line crossed the graph. It crossed here once, and it crossed here twice. Because it crossed, I would write no, failed the vertical line test. Number 3, this is a table. I'm only going to look at my x's. My y's don't matter. Do my x's repeat? The answer is no. Because my x's don't repeat, this is a function. I put a -2 and a +2 in there because I wanted you to see that they are different numbers. It's okay that they're both 2's. One positive, one negative is enough of a difference between those two numbers. Number 4 is a map. We, once again, ignore the range. We're going to look at the domain. And I want to make sure that domain only has one arrow coming out of each number. Now, if I had an arrow, say, like this, 2 arrows coming out of 8, that would make it not a function. So in this case, yes, this is a function. Notice that -4 going to -4, that doesn't matter. The range has nothing to do with it. It's all about the domain. Number 5, let's consider the sequence shown. Let's describe the pattern. Okay, notice I have a row of 1 dot, then a row of 2 dots. My next image has a row of 1 dot, 2 dots, 3 dots. My next image has 1 dot, 2 dot, 3 dot, 4 dot. So, okay, you're going to have to suffer my handwriting a little bit here, but we add a bigger bottom row. Let's draw the next two figures. So the next two figures are going to be like this. I think this will give me an opportunity to do dots. Let's see. Aha, good. So my next figure, this one had 4 dots, so then my next figure has 5 dots on the bottom. 1, 2, 3, 4. Whoops, I did an extra. My bad. No, erase. Oh, erase. I keep thinking I'm selecting the eraser, and it's not. What just happened? Come on. Stroke erase. Ah, there we go. Okay. Beautiful. Let's continue. Now, since my computer's acting up, let's see if it'll do this. Boom. Okay. Are you gonna cooperate, Mr. Computer or Miss Computer? No? What's happening? Oh no! Oh no! Draw. Oh, there we go. Now it's cooperating. I don't know why it chose to wait so long. All right. So then we have a row of 4. Boop, boop, boop. I can't even draw it straight, huh? There we go. Then we have a row of 3, row of 2, and a row of 1. And then the next figure will have 6 on the bottom. 1, 2, 3, 4, 5, 6. Then a row of 5. Then a row of 4. Whoops. Then a row of 3. Then a row of 2, and then a row of 1. All right, my drawing isn't beautiful, but that's okay. Numeric sequence. Okay, so a numeric sequence is counting the dots. So instead of dots, I want numbers. So let's write the numbers down. I'm going to choose my black pen. I'm going to make it smaller again. Okay, so the first image has 3 dots. So 3. The image after that has 6 dots, then 10, then the one I drew has 15, and then the next one has 21. Now, how did I know that without actually counting the dots? Well, yeah, sure, I did memorize it, but check it out. Each time we add one bigger bottom row. So we add 3, add 4, and then we added 5, and then we added 6. So to determine the 10th number, let's add 7. So that's 21 plus 7 is 28. Add 8, 36. Add 9, 45. Add 10, 55. So 55 is your answer. Write the first 5 terms of an arithmetic sequence with a common difference of 2.2 and a first term of 0.2. All right, so since the first term is 0.2, 0.2 goes right there. Now I subtract 2.2, which gives me -2. Then I subtract 2.2 again, -4.2. And again, -6.4, and one more time, -8.6. For questions 7 and 8, let's identify whether the sequence is arithmetic or geometric, then determine the common difference or common ratio. Okay, number 7. Okay, first, the one I like to think about first is it arithmetic? Because that's the easiest one. That means we're either adding or subtracting the same number each time. Okay. So to get from 48 to 12, I would have to subtract 36. Well, if it was arithmetic, I would have to subtract 36 again, and 12 minus 36 is not 3. So that doesn't work. So it's definitely geometric. To find out the common ratio, I'm going to do my second number divided by my first. So in my calculator, I did 12 divided by 48, and I got 0.25. You could also, if you had noticed that we're dividing by 4, if you wrote divided by 4, I would accept that. However, it's more proper to say we're multiplying by 0.25. Okay, next. Number 8, I'm going to try arithmetic again. If it doesn't work, we'll do geometric. Okay, 8 to 11, I would have to add 3. If this is arithmetic, I should be able to add 3 again and follow the pattern. 11 plus 3 is 14. Beautiful. And that's our common ratio, plus 3. Sorry, common difference. How dare I get that vocab wrong? Shame on me. Okay. Next, for the following sequence, let's write the explicit formula. Now, I will write it down right here for you. This is the explicit formula. Okay. We already have the AN. Perfect. A1 is our first term, so 1/2. Then we have a plus sign, so plus. The next thing we have is letter D. D is our common difference. So to get from 1/2 to 1, I actually add 1/2. To get from 1 to 3/2, I add another half. So our common difference is also 1/2. Very coincidental. And we just have n-1 here. We're just writing the formula. Next, we're going to write a recursive formula. This is the recursive formula. All right, so we already have an, perfect. an-1, that's just saying use the previous term. So that stays a sub n-1 plus d for the common difference. Well, to get from 0.15 to 0.17, we add 0.02. Now, if you couldn't remember couldn't figure it out for number 9 or 10, remember, you can always find the common difference by doing the second term minus the first term. Just as a reminder. And same thing goes for this common difference. We can always do second term minus the first term. Some people are good at mental math, others aren't, and that's fine. Whichever way works best for you is the way I want you to do it. Number 11, determine the 20th term of this sequence. Okay, well that means I'm going to plug 20 into n. Now the first thing we do is what is inside those parentheses. So 20 minus 1 is 19. Next we multiply. 3 times 19 is 57. And then I could finally add 2 plus 57 is 59. Number 12. Barkey's Bakery sold 20 dog cakes during week 1 of the operation, 27 week 2, 34 week 3. So let's continue this pattern. So 20, then 34, whoops, then 27, my bad. Then 27, excuse me, then 34. Well, what seems to be the pattern? To me, it looks like we're adding 7 each time. Yep. Okay, beautiful. 34 plus 7 will give us 41. Plus 7 is 48. B says write explicit or recursive. I recommend explicit because it is the most useful. We can use it in letter C. Much easier than using the recursive one. You can always use either one. It's just the recursive one is a little bit more tedious. All right. So, explicit formula. That's what I'm picking. I'm just going to underline it so you know. Oh, I guess I'm circling it. A1, that would be our first term, so that's 20. Plus, you know I got to do my color codes. You know. Okay. Plus the common difference, well, that's plus 7. Whoops, I forgot to switch to a pencil. Plus 7, and let's color code that. Common difference is 7. And since I'm just writing the formula, it's n minus 1. Letter C asks us to use the formula to predict the number of dog cakes in the bakery during week 12. So what I'm going to do is plug 12 into n. All right, let's follow the order of ops. First thing I do is what's inside those parentheses. So subtract. 12 minus 1 is 11. Next, I multiply. 7 times 11 is 77. And finally, I can add 20 plus 77 is 97 dog cakes on week 12. All right, I hope this was helpful. If you have any other questions, please make sure to ask me or your other teachers, whoever you're with. Otherwise, have a wonderful rest of your day. Bye!